So now we are moving on to the next question. Let's go and check what this is all about. Right. So this is a graph question. It's a beautiful graph question. It says to us here, the graph of g of x is negative cos of 2x for x's between negative 180 degrees and 180 is drawn below. So they have a beautiful graph that is sketched for us. Now, when somebody draws a graph for you, they're probably likely to ask you a lot of questions in terms of analyzing that particular graph. So we can see that beautiful graph that you're looking at there. It's nice, yes, between minus 180 and 180. The first question they say here is determine the general solution of 4 sine x plus 2 cos 2x equal to 2. So we have to find the general solution of that question that you're looking at now. Okay, so the idea here is this. Whenever you are doing graphs and you get somebody asking you about the general solution, it's because they're guiding you. They're probably going to ask you to draw another graph, and they are looking for the point where these two graphs intersect, because where graphs intersect, graphs are equal. So when we ask you to find a point of intersection of graphs, it is the concept of the general solution. We're asking you in terms of that, in that context, right? We want you to understand that when graphs intersect, they're equal. When we ask you for the general solution in a graph question, we're just asking you to find where the graphs are equal. So this is guidance. So when you sketch, whatever the solutions you got, you can be able to pinpoint them on the graph to see, indeed, I am actually going to put them where they have to be as guided by the general solution. So please keep that in mind. So now, this question here is a general solution question that is in graphs. So I'm expecting it to be some form of guidance for whatever's going to happen when you start drawing the graph. So now let's look at what we have here. First of all, you will notice that all these terms, 4 sine x, 2 cos 2x, and 2 have a common factor, which is 2. So I can immediately begin dividing all of them by 2, and that will actually lead us to 2 sine of x plus cos of 2x is equal to 1. That is simply what you end up with. And then you will notice something very exciting about what you're sitting with here. There's a double angle, guys, double angle of cosine there, which can be expanded, and we need to expand that double angle of cosine, right? There are 3 versions of expanding the double angle of cosine, and I'm going to pick the one that is in terms of sine because we want everything to look at the same in this question. So what am I going to write now? I'm going to say let's keep our 2 sine x right there, but this one here, we're going to call it 1 minus 2 sine squared x. This information is available in your information sheet, is equal to 1, right? Just changed my double angle in terms of sine. Why? Because I see there's another sign there and I want everything to look the same. You will notice that 1 appears on both sides of the equation, so if I subtract 1, this is going to disappear alongside that one. So this simply leaves us with 2 sine of x minus 2 sine squared x is equal to 0. Again, you will notice that 2 is common as well, so I can divide. In fact, by negative 2, what will happen if I divide by negative 2? This one here will just give us sine squared x. This one will give us minus sine of x is equal to 0. And then I can take out a common factor, which is the sine of x into the sine of x minus 1 is equal to 0. And then from this, we can simply see that according to the 0 factor law, when you multiply 2 things, you get an answer of 0. That means sine of x is 0, or it means that the sine of x in this case is simply going to be equal to 1. Now, I'm going to be very sneaky and use my knowledge of the mother graph, of the sine graph, and the cosine graph to figure out what is going to happen here. According to our knowledge of graphs, we know for a fact that the mother graph of sine needs to look as follows. It simply goes like this. It simply goes exactly like this. It goes from 0 goes to 1 and then comes back and then comes back like that. So we want to know, where is this graph of sine x equal to 0? You will notice that the graph of sine x is 0 at 0 degrees. It is 0 at 180 degrees. It is also 0 at 360 degrees. In fact, every 180 degrees, this graph is going to be 0. So for the first part, I'm going to simply say x is equals to 0 degrees plus k times 180 degrees, because it's going to come back to that 0 every time after 180 degrees. The second one now is this part that says sine of x is 1. So if you think about it, there's 1 here. So when is the sine graph equal to 1? It is 1 when x is 90 degrees in every 360 trip, right? So when x is 90, the graph is going to be at 1. So I'm going to say, so x equals to 90 degrees. But this is not going to happen until we come back 360 degrees later. So that's why I'm going to say k times 360 degrees. And remember to tell people that k is the element of integers. Very important for you to keep that in mind. So this is a technique of manipulating equations. When you know if it goes to sine something or cos something, you can resort back to your knowledge of how it looks graphically. So if you understand the mother graph from grade 10, you can just drag it in here and use it to help you to find the solutions without finding the reference angle and picking quadrants and playing around with those kinds of things. This is how you can do that particular question. Okay, cool. So now I'm going to go to the other part of this question. We're told that the graph of g of x is negative cos 2x between negative 180 and 180 is drawn. We can see there. Now we are asked to draw another graph. We must, for some odd reason, draw a graph of 2 sine x minus 1 within the same interval on the same set of axes. Very important for you to keep this in mind. So we're going to have to go back to that graph paper and redraw the graph of 2 sine x minus 1. Okay, so let's go back and try to draw the graph of 2 sine x minus 1. So we want to draw the graph of 2 sine of x minus 1. This is what we want to draw, and that's going to be the graph of f of x. Okay, cool. So now we use the calculator most of the time to try and figure out how the graph is going to simply look. So I'm going to basically take out my calculator and I want to test all these values that I'm sitting with here. So I'll say, if you look closely, right, I can say 2, and then I'm going to put sine here, and I'll substitute the first angle, which is minus 180 degrees, and close the bracket, and then subtract 1 after that. After the result, I want to subtract 1, and I'm going to get a value there, which happens to be minus 1. So we know for a fact that this graph is going to be at minus 1 when x is minus 180 degrees, and I'm going to put this, right? Okay, cool. Now I'm going to continue with this idea and check what will happen when this x value is not there now, but is now at negative 135. What happens when you are there? And then it's actually going to be at negative 2 point something. It is going lower and lower. You will notice that it's going to be a negative 2 point something. But when you have negative 90, let's go and find out what happens when x is negative 90. You will see that it's actually at negative 3. So we need to go lower now. You could have succeeded to draw it without the use of a calculator, guys, if you know the mother graph, because this is just simply the mother graph shifted 3 units down, right? So it's going to come and be where we are right now. And then when x is 0, let's go and check what happens when x is 0. So when x is 0, you will notice that we are actually going to have a nice answer there, which is going to be at minus 1. It's back at minus 1 again. So I'm going to put there at minus 1. There's my graph. And then when x is 90, what will happen? When x is 90 degrees, you are going to get a solution of exactly 1. So let's go and find out where 1 is. 1 is simply there. And then when x is 180, I'm thinking it's going to come back to negative 1 again. Very important for you to make sure that you don't make any mistake when it comes to this, because if you don't find the correct values, you won't be able to get what you are looking for in the context of whatever is going to follow up as the next question. So it has to be minus 1 for 180 degrees, right? So I'm going to take it back there to minus 1. So how is this graph going to look? Well, it's going to look like this. It must come here. It will turn here. It will go cut over there. It's going to go over this guy, right? And it's going to come again here. It was on its way down. You'll notice that these graphs are going to actually intersect each other in 3 positions, which is when x is minus 180, when x is 0, and also when x is there, and they're also going to meet at that point there. Those are the 4 points that the graphs are going to be equal at. Very important for you to make sure that you can see what is going on there. I've just succeeded to draw the graph. Right, now the last part of our question, let's see what the last part is saying to us. They're saying to us here, okay, this one was saying we had to draw, we are done sketching the graph, we're happy with this part. So the last part says they write down the values of x, for which g of x is strictly decreasing. So we want where the graph of g is decreasing between minus 180 and 0 degrees. Keep in mind the interval that the examiner is interested in. We want to know where is g decreasing between minus 180 and 0. So let's go back and check in the drawing. Let's go back and check. Let's go back and check. So where is the graph of g decreasing? The graph of g from the left. Now I'm looking at it from the left going to the right. Here you will notice that the graph is basically going up. It's increasing, and we don't want that part. We want where the graph is decreasing. And you will agree with me that the graph starts decreasing at this point and goes all the way down this direction, right? All the way down from minus 180, it is increasing firstly until 90, but from minus 90 all the way up to 0, it's decreasing. So the solution where g of x is decreasing, strictly decreasing, is all x values where x is between negative 90 degrees and 0 degrees. please do not include those negative 90 values and the 0. Those extreme values, don't include negative 90 and 0, because at those points, the graph is not decreasing, it is simply turning. So you exclude negative 90, also exclude 0, because that's where the graph is decreasing. A very beautiful question indeed. Thank you for sending us that question. At the turning point, graphs are not increasing, graphs are not decreasing. So if they ask where a graph is strictly increasing or strictly decreasing, do not include those parts. Don't put square brackets, or in inequality notation, don't put the less than or equal to sign, right? Very important for you to keep that in mind.